Okay, and here is SOL topic number 2, characteristics of functions. On this first page, let's review some important vocabulary. Roots, solutions, x-intercepts, and zeros. These 4 words mean the same exact thing. They represent the point or points where the graph crosses or touches the x-axis. You should always write these as an ordered pair. You will have a number, comma, 0 for x-intercepts. The y-intercept, that is the point where the graph crosses or touches the y-axis. That should be written as an ordered pair as well. It'll be 0, comma, some number for the y-intercept. Domain, this is the set of all possible x values or inputs, independent variable, and we read it from left to right for the domain. The range is the set of all possible y values. Those are the outputs, the dependent variable, and we read our range from down to up. Increasing and decreasing intervals, remember that we only use x values and we read the graph from left to right using the x values for increasing and decreasing intervals. Asymptotes, those are invisible boundary lines that the graph will approach but usually not touch or cross. For vertical lines, our equations will be x equals a number, and horizontal lines, our equations will be y equals a number. You see asymptotes with rational functions, exponential functions, logarithmic functions, to name a few. End behavior. This is where the ends of your graph are pointing. And finally, when you see a fancy symbol like f of x or g of x, these are just fancy names for y. You can plug them into your calculator for y equals. Speaking of which, if you do not have a picture of the graph, then please plug that into the equation, into y equals, and hit graph so you can see what you're talking about. Let's look at the first example. The graph of g of x equals log of 2x has, and here are our answer choices. Well, the first thing I notice is that I'm talking about a graph, but I don't see a picture of the graph. So I'm going to pull up my calculator and I'm going to graph it. I'm going to go to y equals, and let's see, I've got a log of 2x. Now I know in a previous tutorial we told you about the log button. If you push math and you go up a couple times, you have the log base. Now that requires you to plug in a number for the base. And since I don't see a number here, I don't really need this symbol. So I'm going to clear that out. If you don't have a number here for the base, you can simply use the log button right here on the calculator. So I'm just going to hit log and put in the 2x. Sounds good. I'm going to push graph and see what my picture looks like. All right, there it is. I'm looking at my answer choices, and obviously we're talking about intercepts. We're talking about x-intercepts and y-intercepts, and I see that it looks like my graph has an x-intercept. Sometimes if the graph is not that good, I might go to a different zoom. I like zoom 4 sometimes. Zoom 4 is zoom decimal. It does limit the x-axis a little bit and the y-axis. It kind of zooms in a little bit, but you can sort of see the graph a little bit better. I can clearly see that there is one x-intercept. So let's see if that can rule out some of the answers. Well, answer A says no x-intercept, so that's gone. Answer B says one x-intercept, so that might be it. Answer C says two x-intercepts, well, that's gone. And answer D says one x-intercept. Okay, so just knowing a little bit, I'm down to a 50-50. So let's go back to the graph and see about the y-intercept. It doesn't look like it touches the y-axis, but the calculator might not know exactly. So I'm going to go and look at the table. If I push second table and see what happens when x equals 0, because that's what y-intercepts are, well, actually, looks like I get an error. That means that there is no y-intercept. In fact, if you push up a couple times, you can see that you're getting error for all of these values because the graph does not exist for any of these negatives, and it doesn't exist when x equals 0 either. So that means that there is no y-intercept. So answer B, one x-intercept, yes, no y-intercept. That is our answer choice.
For this next example, let's take a look at this graph. Remember that roots are the same thing as x-intercepts. The function crosses the x-axis 3 times, so we're going to have 3 roots. And make sure that you write them as points. -2, 0, 0, 0, and +2, 0. The y-intercept is where the graph crosses the y-axis, which also happens to be at 0, 0. The domain is all of the possible x values for the function. Remember, you write the domain from left to right. If you look at the left side of the function, the graph goes on to -infinity, and on the right side, the graph will continue on to +infinity. So the domain of the function is -infinity to infinity. For range, you read the graph from lowest to highest. The graph goes to -infinity and then continues up to +infinity. For increasing and decreasing intervals, you read the graph from left to right. So if you start on the left side of the graph is decreasing. So let's go ahead and highlight that. Here it's decreasing, and then it stops decreasing and turns the other direction and starts increasing. So we'll highlight that a different color. And then the graph starts decreasing again. So we have one increasing interval. Remember, you look at the x values, not the y values. The graph is increasing from -1 to +1. And there are two decreasing intervals, from -infinity to -1, and then again from +1 to +infinity. Remember that end behavior is written as x approaches -infinity, f of x approaches, and then you have to look and see which direction the arrow is pointing to fill in the last part of the statement. As x approaches -infinity means on the left side of the graph, the arrow is pointing up, so f of x is approaching +infinity. And the second part of the end behavior, as x approaches +infinity, f of x approaches, this statement refers to the right side of the graph, which is pointing down, so f of x approaches -infinity.